Okay, what's an ion? People talk about ions all the time in chemistry, so what are they? Well, an ion is an atom or a group of atoms that have an electrical charge. Okay, that's all it is. Now, how does this happen, though? Well, inside atoms, there are two things that have an electrical charge. There are protons that have a positive charge and electrons that have a negative charge. A lot of times in atoms, the number of protons is equal to the number of electrons. So the charges balance out and you don't have any total charge. But sometimes an atom can gain or lose electrons so that it gets more or fewer electrons and protons, and then the numbers don't balance out anymore, and it's left with more negative charge because it has more electrons, or it's left with more positive charge because it has more protons. Let me give you a couple examples of how this happens. Let's look at the atom sodium. Sometimes when I'm talking about atoms, I'll just draw them as the element name inside a circle to indicate that that's the atom I'm talking about. But for our purposes, we're going to want to zoom in a little bit more. Here I've drawn two things in this zoomed in version of the atom. I got protons here in the nucleus in red, and then flying around on the outside, I have these electrons, which I've drawn as black dots. If you know a lot about atoms, you might know that I've left out the neutrons, which also live in the nucleus. But it's no big deal because neutrons don't have a charge at all. They're neutral, so they're not important for what we're talking about here. Anyway, right now, sodium has, if we counted them, 11 protons here in the nucleus, and it has 11 electrons flying around outside. So the number of protons equals the number of electrons, which means that my total net charge is 0. They cancel each other out. And so something that has no net charge, like this sodium atom, we call it neutral. Okay? But here's what can happen in sodium. You see this electron right here? It can lose this electron. It can lose it, and it flies off and usually goes into another atom. So let's look at what happens when this electron here gets lost. And now we're going to end up with a sodium atom that has 11 protons, just like it did before. But now because it's lost this electron, it used to be here, that was here, now it's not here anymore. Now it only has 10 electrons. So now the positive and negative charges don't balance out anymore, and I'm left with more positive charge than negative charge. So this thing now is going to have a charge of +1, one more positive charge and negative charge. And so I can write this, if I want to talk about the atom, I can write it as Na plus to show that it has a positive charge, whereas this, when I'm talking about a neutral atom, I'll probably just write Na. So Na plus here is an example of an ion. It's an atom that has a charge, and it's a specific type of atom. We have a name for this. We call it a cation, which is what we call an atom, an ion, what we call any ion that has a positive charge.
I'm going to interrupt here because it's going to help us with our worksheet. Remember sodium being in group 1, it has one valence electron. Another way we could show this is a dot diagram. Here the dot on the left represents the one valence electron, and when it loses that electron, it becomes Na with a positive charge. The plus or 1 plus means the same thing. Here's that memory tip, LIP, L-I-P. Losing is positive. Lose one electron, charge is 1 plus, because you now have one more positive proton than electron. All right, back to you, Tyler.
Okay, let me show you another example. Okay, so here's an atom of oxygen. The atom that I've drawn here has 8 protons here in the nucleus, and it has 8 electrons outside. So we have the same number of protons and electrons, which means that the total charges balance out. The plus and the minus balance out. So I have a net charge of 0, and I can say that my oxygen atom is neutral. It has no net charge. But oxygen can gain or lose electrons, and actually it really likes to gain 2 electrons. And here's a picture of the oxygen atom after it's gained 2 electrons. And now it still has 8 protons in the nucleus. And if I count up these electrons, it now has 10 electrons instead of 8, which it had before. So now the protons and electrons don't balance out anymore, and I have more negative charge than I have positive charge. I've got 2 more electrons and protons, So that means that my total net charge is going to be 2 minus. I can write the symbol for this ion as O2 minus to show that it has a 2 minus charge, whereas this neutral guy over here, I can just write O. This is an ion because it has a charge, and there's a specific name for it. We can call this an anion, which is the word that we use to describe a negatively charged ion that has more electrons than protons.
Okay, back to you, Ms. Zilski. Thanks. On our worksheet, we're going to be using a little bit different notation. So let's try this one. Here's oxygen with 6 valence electrons. Instead of these pictures, we're going to use the dot diagram. And when it gains 2 electrons, it has a full stable octet. We put that in brackets, and then the charge is 2 minus. Our memory tip, GIN, G-I-N, gaining is negative. Gain 2 electrons, charge is -2, or 2 minus, because now we have 2 more electrons than protons. Now for the 6.4 worksheet, you should have open in Notability. Let's read the introduction. You know that ionic bonds form when electrons transfer. One atom loses electrons and one gains electrons. Guiding question, who loses and who gains? Goal, I can predict the charge of the ion an atom will make. Number 1, start with the yellow and blue periodic table squares. Several are done for you. For each element, draw the element's dot diagram at the top of the box. Valence electrons are shown in red below. The number of dots equals the number of valence electrons. So the ones that are done there have their dots already. Notice the number of dots matches the number of valence electrons because that's what the dot diagram does for us. It shows only the valence electrons. And those are the electrons in the outermost energy level. So we see group 1 with 1 valence electron, 1 VE, it says in red, and there's a hydrogen with 1 dot. And so below that, lithium would also have 1 valence electron. So we're going to put 1 dot there. Going across, I see BE, group 2 with 2 valence electrons and 2 dots. Now, the transition metals have been left off of this table again. They can actually have more than 1 charge, so we're not going to worry about them right now. But if we jump over to group 13, that's where we find B, and it has 3 valence electrons. So I'm going to put 1 on a side before doubling up. Now group 14, the note there says group 14 only does covalent bonding. They share electrons always, they don't transfer. So then group 15 with 5 valence electrons, I see N is done for us with 5 dots. Group 16 with 6, the O, I'm going to do 1 on a side before doubling up. 1, 2, 3, 4, 5, 6. Next one, group 17 with 7, F. 1, 2, 3, 4, 5, 6, 7. And then I see neon with 8 because it's in group 18. And you see helium above it, it's the exception. It belongs in group 18 because it's stable, but it only has 2 valence electrons. Pause here and finish the dot diagrams for the rest of those. All right, I hope you have those done. Let's look at the next step. It says, think. To become stable, will the atom lose or gain electrons, and how many electrons will it lose or gain? Metal atoms have weak electronegativity. They will lose 1, 2, or 3 electrons. Nonmetals have strong electronegativity. They will pull hard and gain 1, 2, or 3 electrons. And then inside the brackets, we're going to draw the dot diagram for the new ion that would form. Let's stop there and do that much. So again, metals, which are on the left side of the table, they tend to lose electrons because they're weaker at pulling, and nonmetals on the right side tend to gain. And they are all trying to get to that stable octet. They get to that stable octet either by losing their outer electrons and then the level underneath is full, or by gaining in order to fill their valence electron level. So when I see H over here, it's done for me. Hydrogen will usually lose an electron. So I see in the bracket, there is no dot on the dot diagram anymore because it lost it. And lithium then below it is going to be similar. Once again, we see patterns with the periodic table. Lithium will also want to lose 1 because otherwise it would have to gain 7 to fill that energy level. And that's just too much, especially since lithium is weak at pulling. So it would rather lose 1 than try to gain 7. So I'm going to leave the picture in the bracket with no dots. Let's look at the step above that says, think, what is the charge of the ion? Losing is positive, gaining is negative. The number lost or gained determines the number of the charge. So losing is positive, and it lost 1, so the charge is 1 plus. Looking at the next one over, Be, it has 2 valence electrons. So it would either lose those and then the level underneath is full, so it would be stable, or it would have to gain 6 to get to 8. So losing 2 is easier than gaining 6. So I'm going to leave the Be in the bracket with no dots. 2 electrons were lost, 2 plus. So that one is done for me. Why don't you pause here and try B, and then when you turn it back on, I'll show you. Okay. So this B has 3 electrons. It would either have to lose 3 or gain 5. Losing 3 is easier to do. I'm going to leave the boron in the bracket with no dots, and losing is positive, so it's going to have a charge of 3 plus. Now we go to N, and we see 5 valence electrons there. Now we're kind of switching gears. It's getting a little closer to 8. It would either have to lose 5 or gain 3. It's easier to gain 3. So now I see there's 8 dots on that dot diagram in the bracket because it had 5 and now it filled that level with 3 more. Gaining is negative. It spells the word gin, if that helps you, G-I-N. Gaining is negative, and gaining 3 means it's actually going to be -3 now. That's the overall charge. Oxygen, the next one over, with 6 electrons, it would either have to lose 6 or gain 2. Well, 2 is easier to do than 6, and oxygen's pretty strong electronegativity, so it will gain 2. So I'm going to show in the bracket the new dot diagram where it's got the full stable octet. Since it gained 2, gaining is negative, it's going to be 2 negative. I'm going to add that up to the right. Why don't you pause here and try F? All right, I hope you did that. F has 7 valence electrons. It would either have to lose 7 or gain 1. F is the strongest electronegativity, so it's going to gain 1. I'm going to draw it here with its full stable octet. After it gains 1, it now has 8 valence electrons. And the charge now, gaining is negative, it has a charge of -1. Pause now and try to finish the bottom row. Let's look at number 2 now. Look for patterns. As usual, the periodic table shows a pattern with the charges formed. Do you see it? Ions in the same group have the same charge. Write that charge in these pink and gray boxes. So these boxes up here are labeling the group below them. And if I look at group 1, I see that H has a 1 plus charge. I see lithium has a 1 plus charge. And you hopefully saw that Na also has a 1 plus charge. So I'm going to put up here 1 plus for that group. Finish this off and submit it to 6.4. If you need more help, remember to talk to your teacher about office hours.
Okay, here's just a little bit of vocabulary for review. So an ion is an atom or a group of atoms that have a charge. Okay, now it's possible for an atom to be neutral, which means it has no charge, means it's not an ion. But if something is an ion, it can be either a cation, which is what we call a positive ion, or it can be an anion, which is a negative ion. Here's a way that I use to remember this, okay? Anion, I think of this as standing for a negative ion, okay? And then cation, you can remember this, it's really cheesy, but you can remember this because cats have paws and a cation is positive. All right? You'll never forget it. I swear, you'll never forget it. Okay, there's one more thing that I want to mention. I've said that an ion is an atom or a group of atoms with a charge. I haven't said anything yet about the group of atoms. So more than one atom can come together, they can stick together and form a group or a clump, and then that whole clump of atoms has a charge. When this happens, we call it a polyatomic ion, a group of atoms that have a charge. Poly means many, and atomic, so you have many atoms together that form an ion. I'll talk about polyatomic ions in future videos, so you want to check those out if you need to learn more about polyatomics. Anyway, just to review what we've learned. We learned that an ion is an atom or a group of atoms that have a charge, and something gets a charge when the number of protons and electrons don't balance out. You have more protons than electrons, you'll have an ion with a positive charge, you call it a cation. You have more electrons than protons, you have an ion with a negative charge, and you call that an anion.